But one more thing I want to show you, just to make a point. We've shown you basically two ways that you can do operations on a large set of numbers, like an array. We showed you how to do it with logical array operations, like you're doing in application 2. And now we show you how to do it with loops and if statements. So which one should you use? I know you're probably more comfortable doing loops and if statements because you learned that first. But whenever possible in MATLAB, you should avoid using loops. You should use array operations because it's much more efficient. All right, so here's an example where we're just going to generate a random array and just calculate some mathematical function. All right, so we generate a grid of x values and then calculate some function y for those x values. First time I do it one by one with a loop. The second time I do it in one line with array operations. And I'm going to time how long each one takes. So you may remember this from 1181. Tick and talk just starts a timer. Determines how much CPU time your program used. All right, so the first way with a loop, it took 320 milliseconds. The second time it took 12. Now you won't get the same numbers every time. In fact, that's an unusually high number. Let me try again. Okay, this time it took 60 milliseconds versus 10. Right, but still 6 times as long. And if this was a really huge data array and you're doing these operations repeatedly, that time really adds up. All right, so if you're programming a robot and it has to do some complicated image processing every time it takes a step, you don't want your robot to have to take a step, pause for 3 seconds, and then take its next step. All right. So wherever possible, vectorize your code, which means use array operations. Don't use loops unless you have to. Another example, this is with a logical array operation where we want to count how many elements of this array are greater than 0.5. Right, so here's the 1181 way. Initialize your counter to 0, loop over the elements of the array, look at each one. If it's greater than 0.5, increment the counter. Here's the better way, sum of x greater than 0.5. That's all you need. All right, so with the loop, it took 83 milliseconds. With the array operation, it took less than 8. Again, that's kind of an extreme difference. Okay, so this time 49 versus 10, 72 versus 8. All right.